Good morning, sir.
Yeah, good morning, everyone. You all able to see my screen?
Yes, sir.
Okay. Let's start with the session for today. Yesterday we were, everyone, good morning. Yesterday we were looking at the strings, isn't it? So you're looking at one particular compound data type, the strings, and we've already seen the character, which is basically defined in Python as a string of length 1. There's not a separate character data type, but they're all strings, and the character is just a string of length 1. And we saw strings more generally yesterday, and we saw all the specific methods that are available only to strings. Strings are also iterable, so they have the indexing, slicing, and all that. But strings are also immutable like tuples, and they have some special methods. And this we saw yesterday. Like we saw the lower upper starts with ends with find and replace, isn't it? So we have replace that is only special to strings. Okay. Then we saw about split and join, which are again some very special string methods. We can split a string on some character that we specify. Similarly, we can join the elements of a list into a string by specifying the separator as well here. And the join becomes then a string method. Okay. All right. So then we saw about how to interpolate into printed values by using strings. And we can use the named arguments, or we can use positional arguments and use the dot format method of strings to interpolate into strings. All right, and then we can also use floating point precision that can be specified within the strings. All right, and then we saw we can have some special characters that can be interpreted as a new line or a tab space, and how we can escape them. Okay. All right. So today let's look at another compound data type. Okay. So what we're going to do today is to look at one more data type, compound data type. So far, what are the compound data types we have seen?
List, tuples,
Okay.
strings,
So we have seen lists, we have seen tuples, and then we have seen strings. Okay. So we have seen three compound data types. Okay. So today we'll see the fourth one, dictionaries. And what are the properties of a dictionary? We'll first try to become familiar with that. Unlike all the other data types we have seen so far, dictionary is unordered. Okay. What we have seen thus far, the list, tuple, and string, they're all ordered, and therefore we could go over them in a sequence, isn't it? We can index them. But a dictionary is unordered. Okay. But there's another way to get the values in a dictionary. But as it is, you cannot index a dictionary. It is unordered. But we can iterate over a dictionary. I'll tell you how. Okay. And the dictionary is also mutable, and it can contain multiple data types. Okay. A dictionary can contain multiple data types. We can mutate a dictionary as well, just like a list. It is iterable, but it's unordered. All right. Now we'll clarify what we mean by unordered shortly. So what is actually a dictionary? It basically consists of key value pairs. Okay. That is, every entry in a dictionary consists of a key followed by a value. Okay. These keys must be unique. Every key must be unique, and the key can be a string, number, or tuple, but nothing else. For example, the key cannot be a list. Okay. Or the key cannot be a set. Okay. It has to be a string, number, or tuple. Only these are permitted to be keys, but values can be any type. Okay. So every item in a dictionary consists of a key value pair, and the set of these key value pairs is called as a dictionary. Okay. And the keys must be unique and can only be strings, numbers, and tuples. All right. Okay. So let's do some demo with the dictionary as we discuss the material. Okay. So let's go to a Python shell. So all of you open your idle. Are all of you ready with your idle?
Yes, sir.
Okay, thank you for that confirmation. Okay, so all of you have your idle open. So let's see how to create a dictionary. There are two ways to create a dictionary. One is just to use these empty braces, and now you say type of D, it's a dictionary, or you can say D is equal to dict of. So dict is a keyword, it's a function, and you create an empty dictionary. So this is very similar to how you create a list or a tuple, isn't it? Okay, when you create a list, you can say either empty brackets, square brackets, or you can say list of and you create a list. So usually there are two ways to create a data structure, either using whatever brackets denotes the data structure or using the keyword. All right. Okay, so that is how we create an empty dictionary. Now, how do we populate a dictionary? Okay, so when you specify the elements of a dictionary, the first you have to specify the key value pairs. So the first thing to specify is the key, and then to specify the value, you put a colon. So key followed by colon, and then a value. That is one key value pair. Okay, so this is how you create a dictionary. Okay, you have to specify both the key and the value to specify any item, and the set of these items constitutes the dictionary. Okay, so how do you specify the key and the value? You just separate them with a colon and then use a comma to move to the next element, and then again you give a colon and like this. So I have an example here, so let's take this example. So the keys here are dad, mom, and size. It can be anything. Okay, and then the values are earth, Venus, and sex. Okay, some dictionary. So this is a, let's say, family. The size is just 2, isn't it, right now? Or let's say it's 4. We'll have some more people added later on. All right. So now let's say this is my family, and I can create this. So I can create the family using this angular braces. Okay. And then I mention the key followed by the value, and the key and the value are separated by colon. So this is the syntax. And then as usual, the elements are separated by a comma. Now we go to the next item. Okay. So this is how we do it. So we have to say that dictionary is basically whatever dictionary we are trying to create is equal to, okay, open these angular braces, and then you have to give a key followed by a value. Okay. And you have to give many such key value pairs, and then the dictionary will be created. All right. Key colon value is the syntax. All right. So that is what we do. There's another way to create the dictionary alternatively. Okay, you can say dict of. You have the dict keyword here. You can say dict of and give named arguments and equal to some values. And each of these named arguments will be taken as the key values. And these will be the mapped values to the key. Okay, these are the keys, the named arguments, and these are the values that are being assigned to the named arguments. Okay, so this is another way. I prefer the first way. Okay. To create an empty dictionary, I prefer this empty braces, and to populate the dictionary, I prefer this construct. Okay, it's much more easier for me to remember. Okay, so you can choose which one you want to stick with. Okay, so for me, I find this very intuitive, and I do that. Okay, there's also a way to convert a list of tuples into a dictionary. So by a list of tuples, we have a list data structure, and the elements are tuples. And the elements must be 2 tuples, that is meaning that each tuple must consist of two values. And so we have tuples, a set of tuples, and each of them contains 2 values. The first value is taken as the key, and the second value is taken as the value mapped to the key. So like that, each tuple is deconstructed, and the family and the dictionary is constructed. Okay, so let's say list of tuples is equal to this. And then you can say family 2 is equal to dict of list of, and now if you just say family 2, you get the same dictionary. Get the same dictionary as family. All right. So that's what we have. All right. So it works. All right. So you can say a list of tuples can also be converted into a dictionary. So there are 3 different ways at least to create a dictionary. Okay. One is by using the angular braces, another by using the dict keyword. Third is by giving a list of tuples as argument to the dict keyword. All right. So now what are the additions possible with a dictionary? Isn't it? So we want to now, we have created a dictionary, we want to move on to the dictionary. First is we can query the dictionary. We don't have an index for the dictionary, but we have the keys. So instead of the index, we use the keys to query the dictionary. Okay, we don't use the index to query the dictionary because the dictionary is unordered, but we can use a key. We can use the keys to query the dictionary. How do you use the keys? It's just like using the index by using the subscript operator. Okay, we have to use the subscript operator. And what is the subscript operator? The square brackets. So we say family of some key, and it will give you the value associated with the key. So let's try that. So let's say family, and I use the subscript operator, and I say family of mom is another key, and I say mom, it gives me Venus. That is the value mapped to mom. Similarly, I can say family of size is my another key, and now it says 4. All right. So all this is possible. Okay. And you can try to have keys which are numbers. Okay. You can try to have keys which are tuples. You try it out. It's possible. Now let's see. I say what is the length of the dictionary, and the length function will work, and it will return the number of items in the dictionary. That is the number of key value pairs. There are 3 such pairs. Okay, and now I can use the membership operator. The membership operator is in. I can find out whether some value is there in the dictionary or not. So how do I do this? Let's say mom in family. It says true. Mom is one of the keys. Similarly, I can say Venus in family false. So what does this mean? Can anyone tell me what this means?
It can identify the key, but not the value of the key.
Excellent. The membership operator looks only for the keys in the dictionary. If the value given is one of the keys, it returns true. But if the value is not one of the keys, it returns false. Okay. It looks only in the keys. Okay, not in the mapped values. Okay. So when you use the membership operator, it looks only in the keys of the dictionary. Okay. So that's the important point to make note. So let's write that as a comment here. Okay, so it says it only checks keys. All right, so that's an important point. All right, okay, now what we want to do is, okay, I have created my dictionary. Now I want to get all the keys in my dictionary, isn't it? How can I get all the keys? So there is a method. The dictionaries have a special method. Okay, so just like the strings and lists have their own methods, the dictionary has some special methods for itself. It is unordered, isn't it? So it must have some special methods. So if I want to get all the keys in the dictionary, I use the method dot keys. Okay, and since it's a method, it has a dot keys of. It's like a function, except that it doesn't take any arguments. Okay, we just want all the keys associated with this dictionary object. Okay, so you just say dot keys of, and it gives you all the keys in a list. Okay, all the keys are given as a list of keys. Okay, that's what it is. Okay, now similarly, if I want all the values, I can get it as family.values of, and give me a list of all the values. All right. So then suppose I want all the items themselves, that is both the key and the value I want. Okay, in order, so if I want to iterate over the keys, then I can say dot keys, because it will give me a list of keys and the list is iterable. Similarly, I can iterate over the value. Suppose I want to iterate over the key value pairs themselves, then I can say family.items of, and will give me the items as a list of tuples. Okay, each item is a tuple here. You see, it's a 2 tuple, just like we had here, isn't it? List of tuples. In the same data structure, the dictionary is written, the items are written, and now since it's a list of tuples, I can also iterate over all the items. Okay, so these are ways to get to iterate over the dictionary. So as I said, the dictionary is iterable. It's iterable only when you use these particular methods of the dictionary, which provide, and then you can iterate over the list. So dictionary by itself is not iterable, but using these methods, we can iterate over the dictionary, because then it produces a list of values. Okay, all right. Now, how do we modify a dictionary? So as I said, as we saw, the dictionary is MIP, so we have seen that it's unordered. We have seen it as iterable. But how do you mutate a dictionary, isn't it? Okay, so how do we mutate a dictionary? Okay, so let's say that I want to add some key value pair to the dictionary. I want to add a key value pair to the dictionary. And but there's no append or extend in a dictionary, because when you say append, you have to append to the last element. That is, there is a last element, there's the index to the last element, but a dictionary is unordered, so there is no last element in a dictionary. Even though you may say that you're given size as the last element, it is not the last element. There's no indexing here in the dictionary. Okay, so you can't append because there's no last element to append. Similarly, you can't extend because there's no last element to extend, isn't it? You extend from the last element and you can't insert or anything. So how do we add to a dictionary? It is in this format. Okay, so what we say is we take that particular dictionary, and what is the key that we want to add? You give the key as using the subscript operator, and you say that key, let's say kids is equal to, so now you're getting some values for the key. So you're creating a new key and you're getting some values. So who are the kids? And you can say it can be Neptune and comma Pluto. Okay, so now if I look at my family dictionary, you see I have a new key here and it's mapped to a list, and the list is the value. Okay, the value is a list in fact. Okay, so the size of this dictionary is now just 4, only one item we have added, but for that particular key you have added a list as a value, and that is also permitted, isn't it? Okay, so in this way I can add new keys to the dictionary. All right, so that's a nice way. Now suppose I want to retrieve the value associated with the key, then all I have to say is family of, let's say, dad. It will return earth. So I can assign this to some other variable as well. Okay, so you can make a new assignment by using the subscript operator. You can also retrieve the values by using the subscript operator. It is indexing, isn't it? Just like we do for the other data structures, we use the index. Here we use the keys to index the dictionary. Okay, to query the dictionary, we use the keys. Suppose you want to remove an entry and say its value, isn't it? Then which entry will you remove, isn't it? So you can only remove by specifying. We use the pop method, but we can specify the key. And when you specify the key, let's say size, and it removes the particular key value pair as well as returns the value associated with the key. So for removing, we use the pop, and the argument is the key. The key must be provided as the argument. Okay. Now you may begin to appreciate that the key is fundamental to the dictionary and why the key must be unique. If the key is not unique, how you will know which size you are to pop? So it has to be unique. And if the key is not unique, how will you know which value to return, isn't it? So the key has to be unique. So that is why it is enforced that the key is unique. It's like how you index the dictionary. And the indices are all unique. It is 1, 2, 0, 1, 2, 3, 4, isn't it? There's no overlapping in the indices. So just like that, the key has to be unique. Okay. All right. So that is one thing. And this returns a value. Now we can also update. Okay, we can add, if you wanted to add one entry, we do it like this. If you wanted to add multiple entries, we use a method called update. And in the update, we provide a dictionary, smaller dictionary, and the values, key value pairs in this dictionary will be added to the given dictionary. Okay, so let's say family.update. So now we have added multiple entries to the dictionary. So now you see we have a baby as asteroid and grandpa as Jupiter. Okay, so we have added both of these entries as separate key value pairs. Okay, you see how we did this. So this syntax exactly follows the extend syntax in list. When we say extend, we can add multiple elements to a list. But how do you specify the argument to the extend? We have to put the list data structure, isn't it? Within square brackets, you give all the elements, isn't it? When you say append, you don't have to give the square brackets. When you just want to add something, you don't have to give that, isn't it? Okay. But when you want to update, you have to give the angular braces and you have to give the key value pairs, just like a new dictionary you're trying to append to the existing dictionary. Okay. And it's not really append in the adding to the last element sense of the word, but append as in adding to the dictionary. All right. Okay, fine. Now, suppose you want to get a value, you just index by the dictionary. There's also a method to get values associated with the key, and that method is called get. Okay, and suppose that key does not exist in the dictionary, it will give an error. Okay, and suppose the key does not exist in the dictionary, you don't want an error and cause the program to crash, but you want to have an error message. then you can say not found. Okay, you can say get some key value. If the key is not found, just return not found. Don't crash. Continue with the program execution. All right. So that is the so we can try these. All right. So let's say, how do you reassign? How do you mutate an element? It's very simple. You can just say family. What is it? You can say family of kids. And you can say this is just Neptune, Uranus, and now it permits you to do that. So you can modify the values mapped to a key. So you can modify the elements. Okay, so that is possible. So let's say a family of kids, and you get this value. And let's say family of grandpa, you get Jupiter. But if you say family of grandma, we still have not mapped it. So it returns the key error. The key does not exist. Okay. But suppose I say family dot get of baby, similar to the using the square brackets operator, subscript operator, says asteroid. But if I say family dot get of grandma, gives me a it doesn't tell you any error. It doesn't return any value. It doesn't provide any error. But I want an error message if grandma does not exist. So what I can say is family dot get. So if you use get, it doesn't throw error. If you use subscript operator, it throws the error and crashes the program. If you say get, it just dies silently, but it doesn't throw error, and the program can continue with execution. But we want some diagnostic message if the key is not found. So you can use a default key message, error message, and you can say not found. Family dot get of grandma, and you can say not found, and you say not found. The key is not found. All right. Right. So those are some of the dictionary methods. All right. So when we do for loops, I want to do for loops in a bit more comprehensive manner, for our class. And when we get to that, after doing the compound data types, I'll show you how to iterate over the keys in a dictionary and all that. Okay. All right. Now, we can also access the elements within the values of a dictionary. A given value may contain multiple elements. And let's say a given value is a list. For example, the given value is kids, and the kids value is a list, and we want to access the first element in the list. So how do we access the first element in the list? So we say family of kids. That gives you Neptune and Uranus. So that is a list. So in this list, I want the Uranus alone. So how do I access the Uranus alone here? Then again, I have to subscript here and say 1. Okay, because family of kids is Neptune and Uranus. Now in that list, I want the second element. So how do I index the second element? Again, I have to say of 1. Then I will index the second element in that list. Just the element alone, the element is returned. So in this way, I can use multiple subscripting of a given data structure. All right. So I hope that is clear. Okay. So we can also remove one particular. So now since now let's say that now you see I have a list. So family of kids is a list, and since it's a list, it has all the list methods available to it. And suppose I want to remove one of these elements from the list, then I can do that. Okay. How do I do that? I say family of kids, and this returns a list to me. And there's a list method to remove certain elements, and I say remove. And what I want to remove is Neptune. So I say remove Neptune, and that will be removed from the list. And now if I say family of kids, all I have is Uranus alone. Okay, because this returns. So remove is not a dictionary method. Okay, but family of kids is a list data structure because that value is a list. And by virtue of being a list, that data structure has a method called remove. So I can use that dot remove method with this data structure. Because family of kids is a list data structure. Family is a dictionary, but family of kids, that value is a list data structure. So I can use a dot remove on that list and remove some element from the list. Finally, I have only one element in the list. All right. So is that clear to everyone? Is that clear to everyone?
Yes, sir.
Yes, sir.
All right. Okay, excellent, excellent. Okay. So, all right. So now if I want to interpolate into a string using a dictionary, isn't it? We saw how we can interpolate into a string, isn't it? These are all string substitutions that we did yesterday. Now let's see how to interpolate into a string using a dictionary itself. So for that, what we need to do is, okay, you have to use the percentage operator, which I said is the old-fashioned thing. But if you want to interpolate a dictionary value into a string, we have to use the percentage. No other go. And it's a percentage yes is what you have to give. But between the percentage and the yes, you have to say what is the key whose value you want to interpolate. This percentage yes means it's a string, but here you have to mention the key. And how is the key specified? It's mentioned within parentheses. Okay, so note the syntax here. You have to put a parenthesis and give the key. And then outside you say percentage and you give the dictionary in which this key is present. Okay. Now how does it interpolate? It goes to the dictionary, it queries the dictionary by this key, gets the value and puts the value here. Okay. So therefore, if you come here, we said the youngest child is baby in family, but in family, what is baby in family? So family of baby is what is queried. Okay, it is asteroid. So it says youngest child is asteroid. Okay, so we can interpolate into a string using a dictionary as well. And this provides some facility when we are trying to print some useful information and all that, isn't it? Okay, so this is useful to us in that those times, right? Okay, so that is all we have with dictionary. Okay, and so the next data structure is this. Okay, so I don't know if all of you are ready for sets. So shall we go into sets as well? So everyone is ready to go into sets? Or shall we do that tomorrow? No response? Shall we do sets today? Shall we go into another compound data type? The last one we do is sets. That's the last one we have. See, after that there's nothing. Okay. So this is the 5th compound data type. Okay, and this is the last one we'll be doing. So do you want some time to practice with dictionaries? And then we'll go into sets? Okay, shall we do sets? Shall we go ahead? Can we do it tomorrow? Okay, so there are many messages. We'll do it tomorrow. Okay, there's another one who's saying we'll do it tomorrow. Why the dictionary has, really overloaded you or something? Dictionary is a bit overwhelming or something. Is it too much we have done already today? I don't know if it's quite straightforward. I mean, all these compound data types have the usual, methods necessary to work with them. Okay, so basically we have the methods that make it easy to work with the given data structure, isn't it? All right, so there's not much of a, otherwise there are not, anything out of the way that is there. Okay, so these are all quite intuitive. These are the things I want to do with the dictionary. I want to get all the keys. I want to get all the values. I want to get all the items. I want to reassign the key to a different values. Okay, and then I want to get the value associated with the key. I want to remove a certain key value pair. Okay, I want to index into the list value of a given key. I want to interpolate into a string, isn't it? I want to update the dictionary. So these are the general things. I want to see whether a particular key is there in a dictionary or not. Okay, so all these are there as usual for all the other that we have for the other data types as well. All right. So yeah, given the but I want to ask, whether you've all been able to go over the functions video that I posted. I posted some tutorial videos in function. I want to know how many of you went over the functions video. Okay, so Mohan has said yes. Okay, I know that those who have gone over it will know that it's very, very useful. Okay, so I want everyone to go over it. Okay, if you go over it, you'll know that it's very useful. It is just like a class session. You can do it at your own pace. In your own time, you can look at it. It will be very useful to you. It is very instructive. you will learn as much as you are doing in class. Okay, so I cannot emphasize this more. I know it is up to you as well. Okay, so the videos are posted. You go over the function video. Okay, so even now, I think since some of you have said that we'll do the sets tomorrow, I'm okay with that. Okay, we'll do the sets tomorrow, all right? So we'll do the sets tomorrow, but now we have some time. If you have any doubts, you ask me all the doubts. Any aspect of Python, anything that we've been doing so far, you have some problem, any doubts, clarification, question, you can raise it. And other people who don't have any such clarification, go back to the video. You can look at the tutorial video right now. Go over the tutorial videos. Okay, so that is my, yeah. So yeah, Mohan, so everyone, we will do the sets tomorrow, okay? And we'll be comparing the compound data types with the sets. Right now, I suggest anyone who has any questions, clarification, please bring it forward. We'll discuss them, we have time. If need be, you can share your own screen and let us know exactly where the problem is. That will be easier for me to troubleshoot. So in this class, anyone is allowed to share the screen. Okay, so that is, I've turned the option on. Okay, so that anyone has a problem, you want us to troubleshoot, share your screen. So instead of me sharing my screen, I will stop presenting and you can share your screen and we can look at your screen as well. So if anyone wants me to do that, the class, we can do that. All right. And as well as, use this time to go over the tutorial videos. They are just 5 minutes to 7 minutes only, and you'll definitely find them useful. Okay. All right. So you can review the dictionaries. Okay. Practice with the dictionary. I'll post the tutorial script for everyone. Okay. And if there are there any questions? Anyone? So Ashita is asking something. Let me just see that, sir. When we call the value of a key into a string, what we have to call the value from a list? Okay, interesting question. So what if we have to call the value from list within a dictionary and we have to call only one index out of it in a string? Okay, let's see how to do this. Oh, that is a complicated question. We have to see. We have to see how it works. All right. So one example we already have is, let's say, family of kids. Let's first try to make this into a list. Dot append of, let's say, Neptune. Let's again append Neptune to it. Oops. Oh, I'm sorry. It's append in square brackets. I mean in parentheses. All right, so now if I say family of kids, okay, I have Uranus and Neptune. Now suppose I want to put this into a string, isn't it? So let's see how to do this. That's a very good question. Let's see if we can do this. Yes. So we get the entire list here, isn't it? Okay, you say kids and we get the entire list. Now suppose you want only one out of this, isn't it? Okay. All right, see, this is another way to do this, and this is probably intuitive to most of you. Instead of putting the key value inside this percentage operator within the string, what I can do is I can just say percentage S here, which indicates the string is to be interpolated. And where I interpolate, I close the quotes and I say percentage operator, and then what is to be interpolated, I give here, isn't it? But here, I give the kids itself here. That is, I say family of kids. So I'm subscripting the family with the kids and gives me the same result. And I think everyone should follow this. I'll also edit my notes to reflect this particular construction because this is much more intuitive and this is much more general. This is how we have been learning. So I don't want you to learn this special construct. It may be confusing. Go with this particular construct. Now, once we have this construct, it becomes very, very easy to do what Ashita wants to do. She wants the first element in this particular list. She wants only Uranus to be printed here. So how do we get Uranus? You can again subscript the particular list. So we have the list object here due to this, and we can index the list, isn't it? I just index the list, and you see now I get only Uranus. So that is the excellent question by Ashita. Thanks for that question. So is it clear now?
Yes, sir.
Yeah. Yeah, so
Yes,
yeah,
sir.
so those are good questions now. Yeah, all of us get cleared on this. And this, I'll also post the session transcript, so you can also have access to this. Okay, so basically what I'm saying is, you just say family of kids of 0, and here you just say percentages to interpolate a string. Okay, and this is the general construct. So forget that we did this, which is a complicated, which is a very special, specific sort of a construct. This is hard to remember, but if you remember this, it's always like this. It's always percentage yes. So therefore, here you can index any number of times that you want. Okay, so it is possible. All right. Okay. Any other questions? So if there are any other questions, please let me know. Okay, not yet. Yeah, so as you review the material, wherever you have some, problems in understanding, make a note of it right then and there, and then make a list of these questions, and then you can ask these questions in one of the classes. Okay, we may have a dedicated Q&A class, or like every class I ask you, is there any question with the previous material? And if you have a question, you just raise it during that time. All right. Okay, so if there are no more questions, I think we can end the class. You can make use of the time to review that tutorial videos I mentioned. I'll post the material we have done today. You can also review the dictionaries, and then we will meet tomorrow.
Thank you, sir.
Yeah.
Thank you, sir.
Thank you, sir.
Yeah. Yeah. Have a nice day. Bye.